All right, let's go ahead and take a look at exam 1 here. First question, which statement about the scientific method is true? The key words here that you needed to look for were observation and experimentation. So C was the correct response. Number 2, which of the following is an example of an observation? And I just wanted to point out that choices A, B, and D were just statements of fact. They were not an observation. All right, next one here, you had to convert to scientific notation. Here we have a number less than 1. That means that we're going to have a negative exponent. And then you can just count over how many spots you need to move it to get the number here, or sorry, the decimal here, and that's 4 spots. And then you also need to make sure that you're putting the correct number of significant figures here. And this is 5 sig figs, so 5 here. All right, similar here, we're just going the other way. So this number is greater than 1, so you should have a positive exponent. Move it 2 spots, and you have 4 sig figs, so this is the correct response, choice C. All right, the next one here. Here we have a thermometer that marks at 1 degree increments. And whenever you use any kind of device like this, a ruler or thermometer where you're doing a manual measurement, you need to make sure that you estimate it out 1 more digit. And if you're working with an electronic device, that last digit's built into there, and then that'll be done for you. So 1 more decimal place, so we give it 1 additional decimal place here. All right. So here, if you're being given a number, just know that the last digit is the estimated one. See number 5, it's a similar question. All right, count your sig figs here. So remember that your internal zeros are significant, and trailing zeros to the right of the decimal are also significant. So it gives us 5 total. All right, here, you didn't technically have to do the calculation here. I went ahead and did it anyway because that's the best way to make sure that you're following your rules. Remember, we follow the order of operations, and then we apply our sig fig rules as we go along. All right, so the first thing we need to do is the part in parentheses. That gives me 0.6, 1 decimal place, so we actually reduce down to 1 sig fig. And then you're doing a multiplication with the 3 significant figure number. So we have 1 in the end, so the final answer should be 7, but 1 sig fig there. It wasn't actually asking what the correct answer was, it's asking you for how many sig figs. All right, this next one here, you actually had to do the calculation. You may notice that all the numbers appear to be kind of the same. So following our sig fig rule, same deal again here. We end up with 1 decimal place for only following the addition and subtraction rule here. So 80.5 is the correct response. All right, next one here, these are just your metric prefixes. 1,000 is for the kilo, and that's not one of the choices here, so it's none of the above. And then, did you guys all get that one? All right, so this is basically 10 to the minus 6, or it's 1 millionth. So it's 1 million micrometers in 1 meter. So we get choice C here. Remember what the symbol was for that? So we're going to put the symbol for it. What do we use? It's the funny looking U. It looks like that. It's the mu. But it looks like a cursive U almost. All right, next one here. So an American nickel, 5-cent coin, has approximately 5 grams, which is equal to, and what I did with the choices here was I converted them all to grams. And you should be able to do that without a calculator now. And it works out where choice B, where we have 5,000 milligrams, it's 1,000 milligrams per gram, so choice B is the correct answer. All right, next one's here. So the first one here, how many milliliters are in 17.5 liter? It's a factor of 1,000 in the conversion here. And I do mention here that you should be able to do this without a calculator. You effectively have 10 to the 1 from this number and 10 to the 3 from this number, which is 10 to the 4. All right, next one here, it's similar, except for we have a unit raised to a power. Notice here my conversion here is meter to centimeter, so I had to cube that term, and that puts a factor of what in there? 10 to the 6. So that's what I did here, 10 to the 6. And then make the choice A. I didn't circle it here, but it's correct on the Scantron. All right, next one here, volume is length times width times height. So you just multiply all three of those numbers. That's where you get your centimeter cubed from. And then similar to the previous question, we had to do a conversion here. And I went ahead and used a calculator for this calculation and get this number. And you may notice here that you have 10 to the 3 over 10 to the 6, which is 10 to the minus 3. All right, a lead ball has a mass of 55 grams. We're given the density. What is the volume? So I showed you two different ways to approach this problem. One is you can just do the algebra and solve for V, or you can set it up at the conversion where we use density as a conversion factor. That's really common if you're going between a mass and a volume conversion. And recall also that a centimeter cubed is also equal to 1 milliliter, so I just went ahead and used that interchangeably here. Didn't actually show that conversion step. All right, this one here, we just go ahead, we're given the weight, and we need to watch our units here. The question is asking for grams per centimeter cubed. So for the kilogram term, I just put times 10 to the 3 in there instead of the kilo. And then here we have the conversion, and I wrote down right here what it should be. It should be 1.5 times 10 to the 3. So effectively, those cancel. And then you end up with punching your calculator, the 1.84 divided by 1.5, and you should have came up with 1.2 as the correct response there. All right. So this one here, we are stacking liquids of different density. And I did mention in here, we haven't covered this quite yet, but liquids that do not have the same type of polarity to them, we'll cover this later on the semester, means they won't mix. So we're talking things like oil and water, we know those don't mix. And what's basically happening here is we have nonpolar, polar, nonpolar. So that layer B here is preventing them from mixing together. And they are going to go from most dense at the bottom, least dense at the top. And the day I talked about this was actually the day I did the rainbow demo. Do you remember me doing the rainbow demo? I actually mentioned here that the more dense liquid goes to the bottom here. And hopefully you read that in your book as well. So the correct order was choice E. And as a side note, I've tried this demo. It's a nice mess that you make. It was actually a big mess that I ended up making, but it worked. All right, number 19, which of the following is not an example of matter? So basically your choices here are going to be something that's matter or something that's energy. And if you look at everything here, they're all matter. So choice D, though, is mentioning heat, and heat is energy. It's not matter. Keep in mind that with choice B there, it's mentioning a gas. Gases still do have mass. Because they're less buoyant than air, we typically don't use a scale to measure their mass. We actually calculate it a different way by using things like their volume and their pressure. And we'll cover that later in chapter 12. All right, number 20, which state of matter has atomic spacing that is close together and indefinite shape? So remember that liquids and solids are packed closely, but you get the indefinite shape with a liquid. All right, number 10, which of the statements is false? So this is questions about matter and mixtures. It works out where all of them are true. All right, next one here, how would you classify Raisin Bran? You have distinct different regions. You have, the flakes, and then you also have the raisins. So it's a heterogeneous mixture. All right. So number 23 is just a definition question. A physical property is one that does not change the composition. It's oftentimes a state change. In a lot of these questions you're going to run across. All right, number 24, which of the following is not an example of a physical property? And it works out where things are either breaking or changing states. So those are all physical properties. However, water can form from hydrogen and oxygen gas. So hydrogen and oxygen independently are not water. So when you combine them, they are no longer hydrogen and oxygen, they are now water. So that is technically a chemical change. All right, what type of energy is associated with the burning of gasoline? I mentioned that all chemical reactions, we say that it's chemical energy. All right, so here is the trick question on the exam. So the key here was recognizing the difference in the lowercase c and the capital C. And recall that if it is a capital C, we say that it is a kilocalorie or a food calorie, which is equal to 1,000 of the lowercase c calories. So you just had a factor of 1,000 here, so you should have ended up with times 10 to the 5. All right, this next one here, this is just a matter of memorization of these different freezing and boiling points, and it works out where choice 2 there was actually the freezing point of water, where 1 and 3 are correct for the boiling point. All right, so here we have some heat capacity questions. So it's saying here that if you have the same amount of heat applied to the same mass of different materials, which one should have the highest temperature? And remember that the lower the heat capacity is, the less energy it takes to heat up. So things that are metallic tend to have really low heat capacities. Things that don't conduct heat well, like water and wood, things like that, tend to have a high heat capacity, meaning you put more energy into them to heat them up. So for the highest temperature change, we had the lowest C, which would give us the largest delta T, and it works out where gold is the lowest. All right, next one here, you had to just do some algebra here to solve for the heat capacity. That's what the question is asking for. I did the math here, punched in the numbers given. I don't think we had to do any conversions. They're all in the proper units of grams, degrees C, and joules. So notice here that no units cancel in this problem. So we end up with joules per gram per degree C. All right, the next one here, you had to calculate your delta T. It's going from 25 to 50. It's final minus initial, which is the difference of positive 25. And then you pretty much just plug your numbers in. You may notice the question does not give you the heat capacity of water, because that's one of the ones that I want you guys to know. So out of all of them out there, that's pretty much the only one that I want you guys to just know off the top of your head. All right, are there any questions about the multiple choice? All right, from what I've noticed here, that's usually where people lose most of their points. So definitely make sure that you practice the multiple choice questions that on the old exam that I have online for you. All right, next here we have the short answers. And in general, I try to make these problems a little bit longer or more difficulty than the multiple choice, because these usually end up being worth more points when I break down everything. So here we had to convert from liters to inches cubed, and here was the path I decided to take, and I chose that because of the common units here of inches and centimeter. However, when we go from centimeter cubed to inches cubed, we have a cube term there, so we have to cube this. I noticed a lot of people were actually writing that out, but when they actually calculated it, they ended up putting a different number here. This should be about 16 or something. If you leave this number as is, I do believe you got about 9 something that most people got as an incorrect answer. So you have to cube the number as well, not just the units. And then watch your sig figs. We start out with 4, we end with 4. These are all exact numbers. Alrighty, the next one here, going from Kelvin to Fahrenheit. You need to do the stepwise. So you go from Kelvin to Celsius, then to Fahrenheit. And if we're going from Kelvin to Celsius, you subtract that number of 273.15, which I actually gave to you here in the problem. And then after you have this degree C, you then go ahead and plug into this equation here and end up with 575.5. And following my sig fig rules, I end up with 4 sig figs. All right, next question here. Another heat capacity question similar to the one in the multiple choice. The difference here was I was asking for the final answer in calories here. So you had to do the problem like normal, plug in your variables, calculate delta T, and then you should have came up with 2.54 times 10 to the 7 joules. And then you convert that to calories by using the heat capacity of water, which was given to you in the equation, but you should know this one. Notice here I used the ethanol one because that's actually what's changing here. But when you're converting from joules to calories, you use the heat capacity of water because that's the definition. All right, the next one here is a similar question here. So you need to solve for the final temperature and then plug in your variables. You may notice here that you end up with an absurdly large number for the degree F. A lot of people did do this correctly. I wanted to point out something though, that look at the melting point of gold. So it's a little bit lower than that. I think you would probably vaporize your gold at this point. I just was throwing in random numbers in here, and this is what it ended up being. So realistically, if I change this problem in the future, I'll change that to be joule, not kilojoule, and then it should work out properly.